Hello everyone, and welcome to my video lesson on radicals and radical functions. So we're going to shift gears here and take a look now at what a radical is, even roots, odd roots, along with some terminology. So please be sure to review over the textbook, as there is some very important terminology in the textbook that we'll be using in this video discussion today. So let's just, by matter of introduction, so just make a few introduction comments. All right, so previously before, we have taken a look at things like 5 squared, raising numbers to a power, and let's just note that that is equal to 25. And let's take a look at 7 and raise it to the second power, which is 49. And let's do one more, say 8 squared, which is equal to 64. But I'd like to also take a look at one other thing, and that is negative 5. And if I raise that to the second power, let's just note that we also get 25. Take a look at negative 7 and raise that to the second power. We also get 49. And let's take a look at negative 8, raise that to the second power, and note that we also get 64. So the question is, given a number, say for example 100, and we want to take the square root of 100, the question then becomes, what does this equal to? So basically what this is asking, if I take a number and square it, what is that number that gives me 100? All right, so we all know that this is going to be 10. So we say that the square root of 100 is equal to 10. But let's also note that negative 10 raised to the second power also gives me 100. So technically, the square root of 100 is technically plus or minus 10. So if anybody ever asks you, for example, what is the square root of 25, technically you should come back and say plus or minus 5. All right. If anybody was to ask you what is the square root of 9, technically you should come back and say plus or minus 3. When you only report back the positive number, say for example the square root of 49 is equal to 7, this is what we call the principal root. So the positive component is the principal root. All right, but technically, the square root of these numbers is plus and minus. The square root of a number is plus or minus. And let's also note that, special note, 1, we do not take square roots of negative numbers. At least, not yet. Technically, the square root of negative 4, okay, we say is not a real number. So we do not take square roots of negative numbers, at least not yet. Another popular one is to take what we call the cubed root. And the cubed root is asking a similar question. That is, if I take a number and I raise it to the third power, what is that number? Okay, and we can continue on. Say, for example, the fourth root. We could talk about the fifth root, the sixth root, the seventh root, the eighth root, the ninth root, and so on. And I think, and the reason why I wrote these out is I wanted you to take a look, and that is we can take the square root. This number up here, technically there's not a number, but there's an implied number. These numbers here, all right, are even. And notice that these numbers here are odd. Okay, so that number that I circled is called the index. Okay, we refer to that number as the index. So this has an index is cube root, so that index is 3. Okay, so the square root, technically we put a 2 there, but the square root is so common that it's automatically implied the 2, so we don't put the 2 in there. All right, so this is called the index, and this symbol right here is called the radical. That's a radical sign, hence radical numbers here. All right, so to take cube root of numbers, so let's just note that we can talk about the cube root of 8, which is what number do we take and cube it. So you can go through with your calculator. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So here we know that this is going to be 2. And we could take a look at the cubed root of negative 27. So again, this one, what do we take and cubed? And notice that this would be a negative 3. So we do not take roots of negative numbers when the index is even, or in other words, we do not take even roots of negative numbers, but we can take odd roots of negative numbers. So note number 2. All right, we can take odd roots of negative numbers. Okay, odd roots of negative numbers. So we're kind of good to go. Good to go there. Okay, so let's take a look at some roots and stuff like that. Take a look at some more square roots. So technically the square root of 81 we know is going to be plus or minus 9. For some reason this is a real tricky one. The square root of 0, well, 0 is not a signed number, so it's just going to be 0. The square root of 16 over 81. So we take the square root of fractions. No, we'll take the square root of the top part. So the square root of 16 is 4. And the square root of the bottom part, so the square root of 81 is 9. So this reduces down to 4/9. The square root of z to the 8th power. When you're working with square roots and you have a variable raised to a power, remember this is asking what do we take in square. So note that it's going to be z raised to the 4th power, because if I multiply 4 times 2, I get the 8. So here's the bottom line. When you have variables raised to powers, just divide those powers by 2. Just divide the powers of variables by 2. Hopefully, but if they're odd powers, you don't do that. We'll deal with odd powers later, okay? Let's just get through the even Steven ones. So let's take a look at the square root of 16 b to the 4th. So note that the square root of 16 is 4 and b raised to the 4th power. Well, the number 4 is even, so we know we're just going to divide that by 2. So 4 divided by 2, so we get 4b squared. So let's note that the negative of the square root of 36, since the negative is on the outside, this is going to be just a negative 6. So let your negatives tag along. But let's just note that the square root of negative 36, all right, we will say that this does not exist or is not a real number. Not a real number. Narn. Gosh, narn it. Okay. Let's take a look a little bit more on cube roots. Again, cube roots, this is about as far as we're going to get. Cube roots. Cube root of negative 1, well, what do we multiply 1 by to get itself? Is 1, and the cube root of negative numbers is always negative. It's a simple thing to remember. So let's take a look at the cubed root of 64. So again, all you can do with your calculator to do these is you can say, okay, what number when I multiply it by itself gives me 64? And in this case, if you go 1 times 1 times 1, you get 1. 2 times 2 times 2, you get 8. 3 times 3 times 3, you get 27. 4 times 4 times 4 is 64. So we get that. We can also do cube roots of fractions. 27 over 64. Again, we won't go too high on these. 4 cubed, 64. 5 cubed is 125 after that. Just break out your calculator. So hopefully we can easily see that this is just 3/4. Okay. The cubed root of x to the 12th. Well, remember with square roots, if we take half of the power in cubed roots, we'll just divide that power by 3. So 12 divided by 3 is 4. This is because x to the 4th, again, if we raise that to the 3rd power, remember we multiply these two powers together. And then finally the cubed root of negative 8 x to the 6th power. All right, let's just recall that we can take cubed roots of negative numbers. So the cubed root of negative 8 is negative 2. And then x to the 6th, so we'll divide that 6 by 3. So we get squared. All right? Okay. So just some simple reductions, simplifying those radicals. We can take this strange thing, we'll get into more detail on the next video, and that is taking the nth root of a number raised to the m power. Okay, we'll get into more detail on this, but this is the nth root of a to the m. All right, and there is a couple of conditions that the author brought up. For example, if you take the square root of a number squared, all right, then this is going to be the absolute value of a number. Okay, and if we take the cubed root of a number cubed, then that's just going to equal to a number. So the idea technically, when you take the square root of x squared, this is going to be the absolute value of x. Okay, and in general, we can generalize this for n even. When we take the nth root of a to the n power, it's equal to the absolute value of a number, and n odd, and we take the nth root of a number to the nth power, it's just the number. Okay, so in other words, if we take the cubed root of x cubed, that just gives us back x. If I take the 4th root of x to the 4th, that gives me the absolute value of x, and if I take the 5th root of x to the 5th, that gives me just x. That's what we're saying. Okay, so let's just note that there is also a difference between negative 2 squared and negative 2 squared. When we put the negative 2 inside the brackets, okay, then this is the same thing as writing negative 2 times negative 2. This one, written this way, is negative, and then the only thing that's raised to the power is this base of 2. So that's 2 times 2. So notice that this is 4 and this is negative 4. So please note that when you take the square root of negative 4, let me say negative 4, all right, this is not a real number, but the square root of negative 4 raised to the 2nd power is equal to the absolute value of negative 4, which is equal to 4. Okay, so that is a big difference. So I'll let you pause the video and scroll that back down and marinate on that one for a while. Okay, so let's just take a look at the square root of negative 5 squared, and let's just note that by the rule this is equal to the absolute value of negative 5, which is just 5. Okay, So the square root of x to the 14th is going to be x to the 7th power. Okay. The fourth root of x plus 7 raised to the 4th power. Note this is equal to the absolute value of x plus 7. And the cubed root of negative 7 cubed is equal to negative 7. And the square root of 3x minus 5 squared is the absolute value of 3x minus 5. And let's take a look. I think I got just one more here. The square root of x squared plus 16x plus 64, which I can rewrite as x plus 8 squared, and this is equal to the absolute value of x plus 8. Okay? All right, and now coming along here to my very last topic here. So the next topic is going to be radical functions. All right, so a radical function then is something in the form f of x equals to the square root of 3x minus 2. Okay. And so what we'd like to do is just to evaluate a few things. I'd like to take a look at f of 6, f of 9, f of 1, and f of 0. So let's note that f of 6 is the square root of 3 times 6 minus 2, square root of 18 minus 2, which is the square root of 16, which is equal to, in this case, it's just going to be 4. This is a special case where we just, when we're working with functions, we just return back the positive component. We don't go plus or minus 4. Okay? So this is a special exception. So this is the special exception. Only positive values. So f of 9 is the square root of 3 times 9 minus 2, which is the square root of 27 minus 2, which is the square root of 25, which is equal to 5. F of 1, so 3 times 1 minus 2, which is 3 minus 2, which is the square root of 1, which is 1. And f of 0 is 3 times 0 minus 2, which is the square root of 0 minus 2, which is root minus 2, which is not a real number. So this is a no-no. Okay? So let's just notice that there are values that we can plug in here for x, which yield back these square root numbers here. It's kind of nice that these all came out as whole numbers, which is not always the case. There is a section in the textbook that shows how to use a calculator to compute things like the square root of 3. I'll leave that for your doings. I'm not going to discuss that. So let's go ahead and let's just note that if we were to take a look at f of negative 1, let's just note we get the square root of 3 times negative 1, which is minus 2, which is the square root of negative 3 minus 2, which is the square root of negative 5. And again, that's not a valid value. So notice that there appears to be values of x which yield positive results. Inside here, the radicand is a positive result. And there are values of x's down here that yield negative radicands. Okay, so let's remember that this thing underneath the square root side is called a radicand. Okay, a radicand. And this symbol right here is the radical. Right? So the question now is, how do we determine the valid values of x? How to determine valid values of x. This is the same as asking, what is the domain of the function? Okay. So remember, when we have even roots means that we must have greater than or equal to 0. So why don't we just take that radicand, 3x minus 2, and set it greater than or equal to 0, and note that 3x minus 2, 3x, bring the 2 to the other side, is greater than or equal to 2, so x is greater than or equal to 2/3. So here the domain for our function is 2/3 out to positive infinity. All right? And we can write that in interval form. So you can see that when you're given a radical function that has an even index, you're going to have to take and turn this into one of our inequalities. And it'll always, the radicand will always be greater than or equal to 0. So let's take a look at the graph of this thing, and let's see if we can't verify this. All right. So notice here we get 1, 2, 3, 4, 5. I think we took that out to 9. 6, 7, 8, 9. I believe that's what we did. Yes, we did. And let's just note that f of 6 we said was equal to 4. So that's this guy right here. F of 6 is equal to 4. So let's just go 1, 2, 3, 4, 5. So f of 6 was equal to 4, and f of 9 was equal to 5. We know that f of 1 was equal to 1. And we know that 2/3 is 0. And we can't go anywhere below that. So again, since that thing takes off forever, again, notice that if we project down to the x-axis, the only thing that's covered is from 2/3 all the way out to infinity. Okay. Now, since we can take odd roots of negative numbers, then we take odd roots of negative numbers, we take even roots of negative numbers, then again, according to our reading, we end up with all the real numbers for the domain. All right, so let's just take a look at another function, call it g of x is equal to the cubed root of x minus 5. And let's take a look at g of 4, g of 32, and I want to throw in g of 0, and I want to throw in g of 1. And note that this is going to be the cubed root of 4 minus 5, which is the cubed root of negative 1, which is negative 1. So this is the cubed root of 32 minus 5, which is the cubed root of 27, which is equal to 3. And this is equal to the cubed root of 0 minus 5, which is the cubed root of negative 5, which is about negative 1.7. And this is equal to the cubed root of 1 minus 5, which is the cubed root of negative 4, which is about negative 1.3. And we can go a little bit more if we wanted. Let's just take a couple of more. So g of negative 2 and g of negative 5, say. And note that this is the cubed root of negative 2 minus 5, which is the cubed root of negative 7. which this comes out to 1 point something. And notice that we can take the cubed root of -5 minus 5, which is the cubed root of -10. And again, you can plug these two values into your calculator and note that you will get. Hi everybody, I just want to take a moment and say thanks again for watching the video. This is our third extra credit assignment. And here's what I want you to do regarding this extra credit assignment. I want you to send me an email. In the subject line of the email, I want you to put extra credit number 3. And in the body of the email, I want you to write the keywords radical numbers. That's all you got to put in, nothing fancy schmancy. I just want you to type in radical numbers in the bottom, and in the subject line, extra credit number 3, and have that sent to me before the warm-up for this video closes. Okay, that's our next extra credit assignment. Also, do not discuss this assignment with anyone. Okay, do not discuss with anyone. Some kind of a number here. So I grab my calculator, I come up with -1.9. And one more computation here. I came up with, plugging it in now, I get -2.2. All right. And if we sketch a graph of this real quick, we can get something that's going to, this thing is going to look something like, here's -1. And at -1, we got, or at 0, we got -1.7. So that's going to be here. It's going to cross here. So it's going to come up something like that. And then it's going to go down something like that. All right, so here again, we can see that the domain is going to be all the real numbers. Okay? All righty, so that takes care of the topics in this video. Sorry for the longevity of this video, but anyways, that's it. If you have any questions or if there's any muddy points, please make note of those in the warm-ups. That's what I'm trying to say. So if you have any questions on this, make sure you put them in the warm-ups, or make sure that you bring them up in class. Okay, bring them up in class. Adios.